There's a link in the phone.
So we have 3 units left and they're all fairly short, especially compared to unit 4. Okay, so yes. So unit 5, we are going to work with the application of integrals. Unit 6 is going to be a mini unit, and then unit 7 will be about the same length as this one right here. Okay, so we have 3 short units to finish out our semester. We will review for the AP test for a couple weeks, and then your final will be to take a full length practice test. I grade it. You can retake 2 of the 4 parts, and then that score, which obviously gets scaled by the AP grading, it will count as a test and a final. Okay, yes.
You say yours do that.
Yes. Okay, everybody doesn't. So like on the practice test, if you get a 5, you'll get some version of an A. If you get a 4, you get some version of a B. And that counts as your final and another test.
Oh, so you're gonna grade it and then show us the grade, or?
Yeah.
And then we can retake.
2 of the parts.
Oh,
Like new parts, but yeah.
yeah.
I have graded your unit 4 tests. For the most part, I'm still catching up on some people, like since it was picture day, people had to like come in and finish. So we'll go over them tomorrow. Okay. So we're just gonna start unit 5, which is in chapter 7. Confusing, I know, just go with it. But chapter 7, our unit 5 is gonna be all about the applications of integrals. So we're going to be talking about area and volume. Area and volume. In this unit, you will integrate with and without a calculator. Please do not tell my 5th hour students anything about our warm-up, okay?
Your 5th hour.
I'm telling Connor.
All right, so let me leave you with a thought here. Not leave you, let's begin with a thought. If I asked you to find the area between x squared, y equals x squared, and y equals x cubed plus 4 from 0 to 1, how do you think you would do that? Connor has an idea. Find the area of both of them and subtract the smaller one, is what he said. Let's draw a picture. Okay. Here is y equals x squared. And then we have this one, right? So I want the area between them. So I want you to think about the area underneath the blue would be this right here, right? And then the area underneath the pink would be this right here. But the area between curves would be just this right here, right? Okay, blue minus pink. Was Connor's idea a good one? Yeah, it was a good one. Okay, so let's just think about this in terms of area. Okay, we know that a definite integral represents the area under our curve. And in terms of these rectangles that are infinitely small, infinitely many. Okay, so what we're going to do is we are going to, like Connor said, find the area of one minus find the area of another one. Now, what's nice, if we're going from A to B, we could actually condense this to just one integral, the integral from A to B of f of x minus g of x. Now, which one should come first? The bigger one. So my hint to you is top minus bottom. You want our top function minus the bottom function, because the top one is going to be your bigger function. This is our concept today. Area between curves. Now, something I will be picky about in this entire chapter. So we're going to start off by finding area. Tomorrow we're going to integrate with respect to y. Cool. Then we're going to talk about volumes in different ways. Volumes by slicing, volumes by taking a region and revolving it about an axis. With every problem that we do, you must draw a picture. Every time. I don't care if you're bad at drawing.
That's true.
No, I forgot about my homework heroes yesterday. So homework hero.
You know, like when did all this work?
What do you mean?
No, I-
Connor, why did you do homework?
Huh?
Why did you do homework?
It didn't.
Why did them like, I didn't. We did half an hour. I didn't call it, so
Probably half.
Okay. All right, so write down this information. So Lance, what does your shirt say?
Pretty sure.
From College of St. Mary?
No, Marty.
Mount Marty. Okay, y equals x plus 6, y equals x squared, x equals 0, and x equals 2. Okay, now here is something about these problems. In the example that I started out with, I said from 0 to 1. In the vague example that you wrote down, it was from A to B. Not always are they going to give us the interval. We are going to have to use our picture to figure it out. So let's draw our picture without our calculators. Can we do that? Okay. Y equals x plus 6. Y equals x squared. Ooh, y equals x squared. And then x equals 0. And x equals 2. What region are we talking about? Is bounded by all 4 graphs. Like the, yeah, sort of looks like a parallelogram with a little curve. So what we are doing is we are taking this region and we are putting in these itty bitty rectangles with thickness dx, and we're adding up all of those areas, okay? Well, how do we do that? We take our integral from A to B. Well, it looks like this region starts at x equals 0 and stops at x equals 2. Which function is our top function? Plus 6 minus which function is our bottom function? Where? This is going to be where a lot of the points are going to come from. Did you draw your picture correctly? With a rectangle, I want you to draw that dx rectangle. You'll know why when we start doing dy tomorrow, okay? And you having the correct setup for your integral, limits of integration and what's inside. Okay, that's where a lot of the points are going to come from. Now, I am going to want you to do this correctly. What? Oh, it's plus 6. I mean, a little bit, yes. So, antiderivative. Cole, give it to me. You got it. Evaluated from 0 to 2. It was 1/2 times 2 squared. Plus 6 times 2. Minus 1/3 times 2 cubed. Minus 0. 14 minus 8/3. What's 14 times 3? So we have 34/3. Is that what you said? Do you agree with Isaac? Promise? Okay. Make the rectangle, please. 34/3. Now, when we have area between curves, our area will always be positive. Area under the curve could be positive, could be negative, but between curves will always be positive. Okay? You believe that? So you have this. Which one is the top function? How about, okay. So this would be negative area, right? Minus more negative area. Wait, what? Are you sure? Are you positive? Write this down. Write this down. What are you complaining about? There's no what? Oh, there's no interval.
So you don't do it.
Oh, hold on. What did you say? They what? Okay, but you said a word. They intersect. So what? What's your problem? You're making fun of me. You're laughing at my picture. Rude. Is that one better? Okay. Now, good news is on the quiz next week, I'll give you graphs to where you'll have like an X and Y axis. Okay. So we have a problem. We don't have an interval. How will we know where to start and stop our interval? We do. And how do we find where they intersect? Set them equal to each other. So they intersect at 0 and 2. I love algebra. Now, do you necessarily have to use an algebraic equation to figure it out? No. You can use your graph, but make sure you double check. Like if it looks like they intersect at x equals 2, make sure 2 squared and 2 times 2 are the same. Turns out they are. Okay, just make sure it works. Okay, now which one is our top function, the line or the parabola? You cold? I'm so sorry. All right, so our antiderivative is x squared minus 1/3 x cubed devaluated from 0 to 2. Four minus 8/3. What is it? Great, good job. You're working ahead. Not bad, right? Okay. What? Are you just now doing that?
No. I'm doing more.
Did you create your own? During my class, you're making Wordles and sending them.
Before we started, yeah, just now. We didn't send it before we started. Show the time.
You mean you sent it before class started?
No.
Okay, write this down. X equals y squared. I disagree with y equals radical x. Disagree.
Plus or minus is pretty.
Ah. Okay. So technically, we have y equals positive square root of x and y equals negative square root of x. So this right here is our region. Okay, I'm going to zoom in on my picture here. I'm going to draw my rectangle with thickness dx. Does anybody see an issue? Oh, yeah? I don't care about positive and negative.
It's like.
Okay. We are not doing this now. You are right. When I draw this rectangle, our top function is the blue. Our bottom function is the pink. What about a rectangle that's right here? The bottom function is different, which means we are going to need two integrals. Because right here, we're going to have to split it up. Okay. So let's figure out what all of these x values are. Okay. What is this coordinate right here? 1, -1. Let's be sure about that. Does 1, -1 satisfy x equals y squared? Y equals x minus 2? Okay. Can we agree that this is 0, 0? What's this coordinate right here? Let's try 4, 2. 4 equals 2 squared. 2 equals 4 minus 2. Okay. All right. So what we are going to do is we are going to have the integral from 0 to 1 of top function blue minus bottom function P green. And then we're going to have to add the area from 1 to 4 of top function blue minus bottom function pink. Okay, now over here, radical x minus negative radical x, same as 2 radical x. Okay, I will let you put this into math 9. I do what I can. Now on your gold sheet, you'll notice the ones where I tell you don't use a calculator. Okay, please pay attention to those instructions. On your gold sheet, I tell you the ones you have to do by hand. The other ones, math 9 it is. You okay? I thought maybe you'd try it by hand.
You know what?
If it's a decimal, change it to a fraction if possible. Math, enter, enter.
It won't change it to a fraction.
I don't think it's that hard.
Did you put all of it in? And what'd you get?
How many zeros did you have?
5.
Okay, so basically it's 4.5.
500.
Okay, so this actually is exactly 4.5 or 9/2 if you were to do it by hand, which Nathan's working on right now. You can attest to this. Okay, your calculator does approximate, so sometimes it's not going to be able to change to a fraction even when technically the answer is a fraction. It's fine. Okay, if you give me 4.500, totally cool with it. Okay. Cole, are you still plugging away at that? Okay, it's thinking really hard. Let's figure out why. To recollect.
I'll do it once I'm not in math class. I don't know. It's this.
Look at that. All right. This is our last problem. Let R be let R be the shaded region enclosed by the graphs. Y equals e to the negative x squared and y equals negative sine of 3x. Making sure your calculator is in radian mode, please put these two in the y equals of your calculator. E to the negative x squared. It is really blown up. Yes. Now, the big mistake on this problem is students assume that that intersection occurs at 1. Does that intersection occur at 1? Nope. Find me the intersection, please. Sure. Second, calculate like in the trace menu. And you can choose the intersection. It should be near 1, right? That's what it looks like. Where'd you get on? That's a load of crap.
1.264.
I just do it.
It doesn't have what? Somebody just walked in to the room.
I know what I did wrong.
Okay.
I didn't have the right.
It says.
Yeah, I got one.
How? 1.1.
Okay, 1.139. Okay, and our top, ooh, which one's the top function? I don't even know.
The one on the left is negative e squared.
Okay, so when you do this in your calculator, first of all, make sure anything that you type into your calculator, you write on your piece of paper. I feel like we learned our lesson a little bit last chapter with that. Please write down what you type in. Now, since you put these in your calculator, you can math 9, 0 to 1.139, y1 minus y2, and then you don't have to type those in again.
I gotta get Y1.
Second.
He has an old calculator.
Oh, gotta hit, EARS.
Mm-hmm.
First, yeah, and then go over to the Y, and then it should be 1. This button. Tell me what button?
He did tell you bars.
Oh, bars. It's like Y bars, Y bars. Yeah, and function, and you can select. Wow, I got that.
Realize this is like the 15th time we've talked about calling up y2 and y1. Okay, so what is the area between curves? A, B, C, D, or E?
I'm not gonna
With the bars, it's a picture in background.
Well, you can like put a picture.
It's a rocket with. I didn't.
Oh.
Mark.
It's not.
Water.
Where was the background?